So I'm the first speaker that actually has this really fine and nice shirt. Shame on you, previous speakers, and the next speakers, you should wear it. So I am the first speaker. I'm opening the testability session, which is really cool. And I'm going to open it with some stories that I'm going to tell about testability failures and testability challenges that we had at Opera, and some lessons that we learned from those stories and the experience of those things that I'm going to tell. So I'm going to start with a small introduction, a definition of testability. Then I'm going to tell you 3 stories about those testability failures and challenges that we had at server-side projects at Opera. Then I'm going to make a kind of main claim, like a main conclusion of those experiences. And then I'm going to back up that main claim with 3 arguments, and those 3 arguments are going to refer to the stories that I'm going to tell. After that, just some random advice and some closing thoughts, and then you can ask questions or share your own stories or talk about whatever you want. So, defining testability. More than really defining it, I'm going to give you a couple of characteristics that I think that are important for testability and that I use to get a feeling of how good the testability is in a given project. And the reason I'm going to do that is because probably my favorite quote ever, especially when talking about technical things, is this one from Ed Catmull, which is, "I don't like hard rules at all, I think they're all bullshit." So I don't really believe in definitions or processes that are rigid or strict or anything like that. I like that things are adaptable. So that's why I'm going to give you a sort of vague notion of what I'm thinking when I say testability, when I have testability in mind. So those 3 things are these ones that you can see there. The first one, before I talk about this, we were joking, Ross and Tracy, where are you? Hello. We were joking earlier that we were having several talks on testability, and probably everyone would give a definition, and probably all of those definitions will be completely different. It's probably going to be true, but I think my sort of definition is kind of compatible with everything that is going to be said and everything that has been said so far. So anyway, the first characteristic that I think is important for a project to be testable is having unit testable code. Having code that has good APIs and doesn't give you problems when you want to write unit tests for it. The second characteristic is, I call multiple deployments. It's just that the project makes it easy to make multiple deployments or multiple installations of it, and all of them work, have the same reliability. So the point of this is that you can recreate the environments that you need to run your test cases, and you know that when you run your test cases, you are going to have exactly the same behavior when you have the production code, like everything live. And the third characteristic is introspection, which is the ability of a system to give you information about itself, about how it's behaving and why it's behaving the way it's behaving, like internal state. So when we started that project, Overlink, we had a number of challenges. The first one was coordinating different teams. And here I'm emphasizing the word different because not only they were different in the sense that there were more than one, but they were actually very different teams. The size was different, the technology that they were using was completely different, the mentality was different, the way of solving problems, the way of seeing the project, everything, all that was different. And that sometimes would give some problems because sometimes when we were discussing bugs or how to fix something, people would have completely different opinions about where things should be fixed or how they should be fixed. We started with 3 teams. We had the server team, the Opera desktop team, and the Opera Mini team. Opera Mini is one of the mobile versions of Opera. So of course, what happened is that typically the server team would say this bug is obviously a client problem and the client has to send like proper data and it's a bug and they have to fix it. And of course, the client would say, no, obviously that has to be solved on the server because the client can't be bothering about that kind of thing. So because of those discussions, another challenge that we had was deciding who had the final word, so when we couldn't agree, we could go forward. This wasn't completely trivial when we started because the different teams were completely independent. So we had to find a way to make someone kind of the owner of those decisions and that people in different teams would actually listen to that person. Also, we had some problems with the first specifications that we had. We thought that they had all the information that we needed, but obviously they were missing a lot of details. And when we were missing those details, different people would make different interpretations of those things, and that gave some problems. We had actually a really big issue, the first iterations between Mini and desktop. Also, because of these details that we were missing in the spec, sometimes it wouldn't be clear how much the testers could test, like how much detail they could test, so to speak. So that led to sometimes having unintended changes. Like sometimes people would fix bugs or refactor code or do whatever change, and those changes would make unintended changes in the behavior, but we would miss some of them because we didn't have all the detail that we should have had in the specs. And probably the most important challenge that we had when we started was finding the source of each bug. Typically, we would have these three components that had to work together, and when we had a bug, it wasn't completely clear where the bug was. So finding that source actually took initially a lot of time, and that was kind of a problem in the project. So what did we do faced with these challenges and these initial problems to kind of fix them? So the first thing we did was documenting the obvious details. And I'm using quotes there because it was kind of funny that a bunch of people thought that it was obvious, and they thought it should obviously be A. Some other people would think that it was obvious, but it was obviously should be B, and they wouldn't even talk about it, and they would make components that didn't work well together and so on. So those details that seemed obvious for a lot of people, they were not that obvious, so documenting them was actually a really important thing that helped us a lot in the long run. Writing a good server test suite was also very useful because that allowed us to, when we had a bug and we were not sure what was the source, we would write a test for the server. So if the test failed, we would know that it was a server bug, so we could do TDD because we had already a test written for it and so on. And if the test passed, then we could rule out the server from the equation, from the problem, so we would know that we had to look for the bug in the clients. And finally, another thing that we did that was really helpful was adding a sort of hidden option that only internal testers at Opera had access to that logged the traffic on the client. So if you could reproduce a bug, you could enable log traffic, that monitoring. So you would go through those steps that would reproduce the bug, then you could go back and see what had happened and examine that output. Similarly, we also log traffic on the server, which was useful when we had, say, a bug that involved both desktop and Mini. So it was much easier to just log on the server a certain account, and regardless of what product or what installation you were using, we would have all the information in the same place. The second story that I want to tell is related to a different project, the MyOpera project. MyOpera, in case you don't know, it's the Opera browser user community portal or user community website. So this project is quite old, and it started as simply support forums. So we initially only had those support forums, and then we started adding some features and modifications and changes and whatnot. And it ended up becoming more of a kind of social network. So from the initial support forums that we ended up having a lot more features and a much more complex site that had blogs and albums and the initial support forums and user groups and whatnot. So as I was saying, this is a quite old project, and around 4 years ago, there was this kind of tipping point where MyOpera became more important for the company, and we wanted to spend like more resources on it. But up to that point, and it was already a quite old project 4 years ago, up to that point, the MyOpera project hadn't had any testers. And that was really bad, because the testing was done by the developers or the front-end developers or whatever. But the problem was that after all those years without having testers, the main problem wasn't that it had this or that bug, or that this or that thing wasn't reliable, or that this or that thing wasn't scalable, or anything like that. That wasn't the biggest problem that the site had. The biggest problem the site had was that it was really hostile to testing. It was really time-consuming to test, and it wasn't reliable to test. One example of that, there would be some features that, for whatever random reasons, they wouldn't work on internal installations. So if you were testing those features, and of course in an internal installation, and they wouldn't work, you would never be completely sure if they didn't work because they are not supposed to work in internal systems, or they didn't work because the code was actually broken and they were going to be broken when you went live. So I insist, around 4 years ago, when we had this change, what did we do to counter this situation and make MyOpera become a much more maintainable, much more reliable, much better project? We did a bunch of things. The most important thing was removing the testing roadblocks. This removal of testing roadblocks, of course, it wasn't an easy task that you can just go to the BTS and say, file a bug, remove testing roadblocks, and assign to someone and get fixed in a week. Of course, it was much more complicated than that. We had to go through the site, see the pet peeves of the testers, and see the problems that we had when testing the site, and file a bunch of relatively small bugs, things that we had to fix, and kind of lobby and insist and make sure that those things got fixed. So when we fixed all the important testing roadblocks, that allowed a lot of very good things to happen to the project, which wouldn't have happened if we hadn't removed those roadblocks first. So the first thing that happened was that we could write automated functional tests that were reliable. That was a very important thing for us. So we reached a point where we had enough functional tests that if you broke fairly big things, we would start catching regressions. And at that point, we added continuous integration to the mix. So every time people committed, they will know some mail will be sent and whatever, and people will know if they had broken something. So we started gaining momentum on that trust on automated tests and the team being more like automated test oriented and so on. So at that point, what we did was writing even more functional tests. And when we had enough of these functional tests and most of the functionality of MyOpera was somehow covered by tests, so we were quite confident that if you were breaking something, the continuous integration system would tell you. At this point, we had enough trust in the system that could start doing heavy refactoring. We didn't really like the code that much, and we wanted to make a lot of changes, but of course it was too dangerous to do all that before having continuous integration, automated tests, functional tests, and so on. So once we had removed components and add in the place new, more modern components, so we rewrote the code so we had better APIs and everything was better, at that point, we were ready to write unit tests, which was another really important milestone in the sort of quality management of the project. Of course, those unit tests were also in continuous integration, so most things that you could break that were important, we would catch. And the third story that I wanted to tell is again about Opera Link, and it's about how the Opera Mini team had a quite big technological change, and they had to rewrite the link support that they had. So when the Mini team re-implemented the Link client support, at that point, the Opera Link project was relatively mature. It was around 2 years old, and we had a quite stable API, and we didn't have any big problems. Everything was quite reliable and was working really well. So there was this assumption that when they re-implemented, just testing from the end user point of view, that would be enough to have a good implementation in Mini. But that was actually a big mistake, because all the interesting bugs were actually at the protocol level, at the low level. So a bunch of those bugs that were the really interesting ones would make it look like everything was working correctly. You would get all the data replicated, and you would go to the second installation, you would get the changes that you were doing from the first one, and so on. But those bugs could add, say, race conditions, or make corner cases fail, or make the service a bit less reliable, or they could simply work perfectly from the functional point of view, except that they would add more load to the server. We actually had one such problem. So, of course, when you are testing internally, you only have like dozens of clients or something like that. You wouldn't notice those things, but when you suddenly went everything live and you had millions of people using the service, then you would start seeing that you have too much load on the service and you have problems and you have to do something to counter it. So in this case, what did we do? What kind of solutions or what kind of things did we go for? The first thing was actually convincing people that it was important, convincing people that UI-centric testing wasn't really going to cut it. So we needed better tools and more low-level tests and so on. And after convincing people, one of the changes that we could make was adding some mobile test tools. For example, some small tool that would give some internal information about the internal status of the link client or whatever else that was useful when tracking bugs. Another thing that we did was adding the ability to switch the link server, what the client thinks that the link server is, basically the URL to the server. A lot of people didn't see that much value in this, didn't understand why it was so important for us, but if you think about it, it's really useful to have something like the ability to change the idea of the client has of what the server is. Because say that you're working on the server, you have refactored code, you have made whatever changes, and you have the common release of the server, say that you're going to release in 1 or 2 weeks or something, in some staging server. If you can't make Mini, in this case, connect to that staging server and do some integration tests, you won't be completely certain that when you go live, when that upcoming version of the server goes live, you're not going to have problems. Other uses that you can have for this ability to switch the link server was related to another thing that we did that was quite useful, that was writing a fake server only for client testing. So this server would more or less behave like the real link server, only that it wouldn't really store any data, it wouldn't really implement the functionality of the link server. It would just check the incoming requests from clients, that they would check that the requests were correct and they were correctly formed and they had all the elements that it should have and it didn't have any extra elements that shouldn't be there and so on. And then it would return canned responses to the client to see how the client behaved and what happened with it. So after all these experiences in this and other projects, the main conclusion that I got from them was, or the main lesson was, that you have to fight for testability, hence the military themed pictures that I've been showing. So in case you're wondering why I think that, you are lucky, because I have some arguments to back up my claim. The first argument is that testability is the only way to scale. Scale, I'm talking about the size of the project or the size of the team, or having different teams working together. So this maps to the first story that I told, that was about how the OperaLink project started. So why do I think that? When you have good testability, that allows you to have good tests. And this is always important, but it's even more important when you start distributing into different components and different teams and so on. That is even more critical, that you have information about how each component works, so you know that you can tell that the integration will work correctly. It also allows for tests when needed. Even if you haven't had time to write all the tests that you would like to, you can always, when you are close to a release and you don't have time to write all the tests that you would like to, you can always verify bug fixes or do quick checks and so on if you have a good enough testability. Good testability also shows how systems work, which again is something that you want anyway, but it's even more important when you grow in size of the team and the components that have to interoperate. And it also lowers the barrier to entry in two senses. In the first sense, you can add developers or change developers in the teams that you have. And in a second sense, you can add more components or more teams working on other products that have to be part of that ecosystem that you already have. And it will be much easier to tell for those new developers or those new teams how everything is supposed to work. And perhaps most importantly, related to the story that I told, having good testability helps isolating root causes. That was one of the biggest problems that we had when we started. So having good testability allowed us to separate where the bugs were, so we could tell where to fix stuff or who to blame, which is more fun. So the second argument I have is that the more testable, the higher quality. And this maps to my Opera story that I told. The more testability you have, the more tests you're going to have, because the less energy and time that you need for each test, the more you're going to end up having. The more tests you have, the less time that you spend on bugs, the less time you spend tracking them, figuring out where the bugs are, the less time you spend fixing them, the less time you spend verifying that the fixes are correct, etc. And the less time you are wasting, if you wish, on bugs, the more time you have for features and the more time you have for refactoring. And of course, refactoring also leads to better code. So in the end, more features, more refactoring, better code, you have more quality. And the final argument that I have is that testability doesn't come for free. And this maps to the second OperaLink story that I told about how the Opera Mini team had to rewrite the link support. I have seen a lot of people that either really believe or they behave as if they believed that if you can use a product, you can test it. That's wrong. Not necessarily you can test a piece of software effectively just because you can use it, doesn't mean that you have repeatability, that you can easily set up test environments and test cases and be sure that if that works, everything is going to work in production, for example. Just because you can use it, it doesn't mean that it's going to be easy to automate. And even though automation, you may not consider it a requirement for good testing, the bigger your project is and the bigger your team is and the more complexity that your project has, of course, the more important that automation, the more important automation becomes. Again, just because you can use a product or a project doesn't mean that it's easy to make multiple deployments of it and that those deployments are reliable. And just because you can use it doesn't mean that the project will give you information about itself, so you will have all the information you need to track down bugs, to verify how things work, etc. So those were my arguments, and now some closing thoughts. I'm going to start with some advice and then some final conclusions, and then you can ask whatever you want. So probably the most important advice that I can give you is think before you cross. Especially here in India, that's really important. Think and look before you cross. Don't forget that. And some less important advice that I have for you, think about what takes time. If you have processes or tasks or things that you have to do in your project, particularly in testing, that take too much time, and here I am defining too much time as enough time that people don't do them as often as they should be doing them, then you probably have a problem and you should look into it and you should try to make those things quick. Similarly, think about what you don't know. If there is some information that you need in order to debug something, to work on something, to fix something, to figure out whatever that you need, if you don't have access to that information, try to create a tool or an option or whatever is needed to get access to that information so you have everything you need to do your work. Third, think of the children and think of the developers, because developers are also affected by these things that take time or by those things that they don't know. So developers, these things are not only for testers, and developers are probably also good source of these pet peeves or these problems that you should be fixing. When you're talking about testability, don't, like in your project, if you want to improve your testability, don't just talk about it like very vaguely, like we have to have 20% more testability or something like that, because that doesn't solve any problem, that's not constructive, and people are just not going to listen to you because that doesn't mean anything for anyone. So try to come up with concrete things that will improve testability in your project, and if you can, extra points if you can implement those changes, because you won't be like annoying people, and you will be able to show how usually relatively small changes can have big impacts in the long run. And especially for those people that might be skeptical about the whole testability thing and why these things are so important and stuff, show them the results. Make sure that when you fix some testability problems and stuff, show them that now this and that thing is much easier or is much faster, and even it might be much easier, much faster for them when they are trying to fix bugs. And some final conclusions. You should think of testability as a roadblock. It's something that it's there in the middle and it's not going to allow you to go as fast as you could be going. So that is something that you should try to get rid of so you can get sort of maximum speed. And here I'm talking about the project. I'm not talking about testing. I'm talking about the whole thing, testing and development. So don't think of it as testing is going to be slower. Think of it as my project is going slower. Tester heroics in the sense that when something that should take 10 minutes takes an hour instead, so testers work 6 times as much because things are just slow and stuff, that is bad. Unless you don't have any other choice because you have a really close release or something like that, avoid that behavior, avoid those kind of heroics, and try to, bitch and moan about the crappy tools that you have and whatever, and try to change that thing because it's going to have a big impact in the long run. And if you have changes that you can make in your project and in your code that helps your testers or helps your testing and your debugging and stuff, don't be scared of adding those things into your project. It's not a hack, it's not bad, it's not like to be frowned upon or anything like that. It's good, it's going to help your project, so just add it. Don't clutter the end-user interface or something like that to add those things, but it's completely okay to add parameters, for example, command line options or hidden buttons or hidden whatever that your testers will find useful, or anyone that is testing, including your developers, will find useful. And kind of wrapping up, kind of final conclusion, opacity is the enemy. The less transparent your system is, the more problems you are going to have with it. So if you want to ask anything or make some comments, share your own stories. Don't ask these questions, please. I don't know them. I don't know the answer. Meanwhile, you can see the credits of the awesome pictures I used in my presentation. So, anyone?
Hello. I just want to understand, are there any established metrics, by which, we could have...
Repeat again?
Okay. Are there any established metrics? Okay, metrics.
Metrics.
Okay, which could help us, to have an idea, with regard to the effectiveness or efficiency of a particular testability of a project, right? I know, like, there are a set of parameters, okay, which could help us to derive us the testability of a project or a product, right? Could be resources, environments, a number of those things. But can we think of any metrics, okay, which could actually help us to have an assessment, fair of assessment to see how good this testability of this project?
Yeah, I think something as abstract as testability is really hard to have like good metrics for. So I guess James Whitaker was talking about making up the number and make people challenge you that you're wrong and so on. I guess it's so hard to measure that you have to kind of agree, like, have the opinions of the team and stuff, but I'm not sure if there is anything that is objective that you can measure that is easy to... It's really, I don't use anything like that.
Hi. So with those examples, it seems like these testability measures have been sort of retrofitted afterwards. I wonder whether the success of these testability improvements have helped people realize that these should be added earlier on, and whether you now see people adding these sorts of hooks and mocks and things earlier in the sort of implementation phase.
So you're asking, sorry, repeat the question?
So after these examples where the testability has been sort of retrofitted in, has this encouraged people to add testability earlier, or are you still retrofitting testability to new products?
I think so. I think so. In the Myopra case in particular, I think there was a really big shift after we added all these tools, because people realized that they were really helpful, and we also had the team changed also, so the sort of the new team was also more receptive to those things. But I think that showing people, when people see how useful those things are, I think that encourages them. For example, we used to have some people that were still kind of skeptical about the whole automated testing, because sometimes things will break if you change some link text or something like that. Like, we had some silly issues like that. But over time, those people, when they broke things in continuous integration and stuff, they started paying attention, and they started thinking that it was like a really big deal and something important and something that we had to work on. In the Link project, I would say yes, but I'm not so sure. We had more unit tests and things written by developers after like the initial efforts of good server test suite and so on. So I would say that we maybe not as much as I would have liked, but yeah, I think people believed more in this thing and were encouraged to write more testable code or pay more attention to those things. I think so.
Esteban, have you found it difficult to sell these ideas to product or project management in the sense of how much time are you spending in a sprint relative to feature development? And if you have found this difficulty, what would you say has been the way that you've gotten around it or how you've sold these ideas?
I think the best way to sell probably any idea, but in particular something as abstract as this thing that is sort of long-term and people have to wait a bit in order to see results, is one of the things that I mentioned in one of the slides that was showing the results. Usually people, if they are not used to these things, and they are probably not used to these things if they haven't thought of them themselves, they are going to be skeptical to like words that they don't understand or something that requires a lot of work, and then they are promised that in the long run, things are going to be okay. So that was one of the reasons why in my Opera, for example, in particular, I started writing that functional test suite, those automated functional tests. And I started writing them just by myself. And I didn't involve like anyone else in the team or anything like that because I wanted to work on them myself until I thought that they were useful, then showing to people so people could see, not that now I'm going to start with this testability thing and maybe in 2 months they will see something. But I wanted them to see directly some results, something that they could sort of relate to, and they could see a concrete good things that they could get out of it.
Okay. Hello? Okay, got it. It's working, I don't know. So, I'm actually curious, how do you introduce a testability for legacy code? It's that's built with no idea that someone in the future will come and talk about what's a testability into their company.
So the question is, how do you go about testability with legacy code?
Yeah, right.
What do you do? My Opera was a perfect, completely perfect example of that. Because as I said, like the first years, it wasn't such an important project, it wasn't that big, and it wasn't so critical for the company and stuff. Back then, absolutely nothing of like testability or testing or those kind of things were like thought of or designed for or anything like that. So I think that the approach that worked the best was what we did. That was, we can't really change the code to make it testable and good and whatever, because we will break a lot of stuff and we won't know that we're breaking a lot of stuff. So that's why I wanted to start with the functional side. So we could, by changing very little code to make it work more like the production environments, that was like enough, very small changes. And I could start writing those functional tests. So we started building this kind of safety net. So once we had that, we could start like really rewriting code and remove the legacy parts that we didn't like and make like, put new modern modules as part of the code base. So I think in general that's the best thing that you can do. If you legacy code, you don't trust it, don't change the code or change as little as you can. Start with functional testing, then you'll see when you feel comfortable enough to start changing stuff. Anyone else? Thank you very much.